Okay, thank you. So we will follow our thumbs up rule only. So this will give me on the screen what actually we are like going through. So let me share my screen once with all of you. First, I will show you some very basics of t-test, in which condition we have to apply paired sample t-test, in which condition we have to apply the unpaired sample t-test, and what are the numbers we need to focus whenever we are learning a Jamovie, SPSS, and the other applications. Remember, even though we are practicing on SPSS, we have the same principles for the unpaired sample t-test. So let me show you some basics of t-test. I'm audible now?
Yes, sir, you are.
Okay, perfect, perfect. So first, we are going with a very simple screen, like a very plain screen. So I just wanted to show you what are the very basics of the analysis part, because once we are going to the SPSS part, so that should not make you confused like what actually we are doing now. Now, the unpaired sample t-test, simple way. We have two type of test in t-test. Then the one is what a unpaired sample t-test. The other part is what a paired sample t-test. Then unpaired is also known as what a independent sample t-test. Sample t-test. Then in a simple language, sometimes we use unpaired, sometimes we use the paired sample t-test. Now comes the principle where we need to apply this type of test. Done. So if I take a very simple example for the paired sample t-test, paired sample t-test. Now suppose in the present class, we are having around suppose 50 plus individuals. Done. So without creating any groups out of it, like simply there is no male, no female. Correct? I'm just taking all together in one shot. All together in one shot. Like similarly, there is no UG versus PG. There is no student versus faculty. Then I am directly taking all of you in a single shot. Then there is no other classification before, after, nothing. Then I am just taking a single group. Now suppose if I am testing all 50 now, and I'm checking all 50 after some sort of intervention. Done. So in this scenario, I need to take what? A paired sample t-test. Then remember, what is the principle? We should not be having any sort of groups. Then if I am taking all together in a single shot, before after treatment, before after the intervention, before after the education part, before after the class part, all together. Done. So in such scenario, I need to take what? A paired sample t-test. Done. Do we have any doubts, any questions now with respect to paired sample t-test? Anyone? Anyone? Clear? Others? No one? Like no doubts, no questions? Just give me a 5 minutes. Just 2 minutes. One important call. Just 2 minutes. Okay. So would you please clarify, briefly repeat? Okay. See, let me remove all these things to make things simple. Now, the first thing what actually we are touching is what a paired sample t-test. Done. In paired sample t-test, what we actually do, we take all individuals in a simple way. So automatically, we are not creating any groups like suppose male versus female. We are not doing any suppose UG versus PG or suppose PG versus PhD. There is no groups. We are taking all of you in a single shot, in a single way. Done. So if I'm taking you all in a single way without creating any groups, correct? There is no groups. Suppose in this class we have a sample of 40. So I'm taking all 40 in a single column and after the education part again all in a single column. But there is no other differentiation. Done. So in such scenario, we need to perform what? A paired sample t-test. Done. So in simple way, what I am checking, do we have a change in a mean value before after the intervention? That's it. So if I need to look for this part, this is what we can do. A paired sample t-test. Doubts? Question? Anyone? Others? Anyone? Amandeep? Dr. Girija ma'am? Anyone? No? It's a simple thing, no? Like before after thing we are doing. A very simple thing. Before after. That's it. But there is no groups. A single thing we are taking. Done. So this is what we are just checking a change in a mean value, change in a mean value before after, before after in a very simple way. Before after. There is no other groups. Correct. Now the other thing is what? Suppose I am taking all of you 40 together. Done. I took your scores before after, again before after, but I need to know like which group has done much better. Is it male versus female or faculty versus student? Faculty versus student. So which one is doing much better? So if I need to compare only two groups, done. In such scenario, I need to perform what? A unpaired sample t-test or we can say independent sample t-test. Done. Doubts? Question? Anyone? Got it? Others? Blank after login and not opening. Bhavika, did you try my method like what I have shared with you? That last folder in the SPSS folder. Still the same issue. So like, are you holding I3 or like I5 port? You have I5. Okay. See, the thing is, in the I5, you need to see your processor because sometimes even after we have I5, we have some technical like a background issue also. So you need to cross check those things as well. Please cross check because even in my last laptop, what I was having that was i5, but I think some RAM issue was there, some like a RAM power something. Even though i5, that was the major issue for all my application part. So I changed to latest version, even though i5, but all the latest versions. So please cross check it once. So like if we have anyone in the class with a good technical background, I think they can help you. It's not about buying the laptop last month. It's about the software, whatever you are having inside the laptop. Even though you have i5, but you need to check the processor, like which RAM, like a memory, something what you are holding. So let me talk to my one of my friend. He is from the IT department. So I will let you know all these things. That's what Jaydeep. See, the thing is, even for my last laptop, I was having i5, but it has some like a problem with some technical, like very old things it was for like having. So I changed to i5 again, a same processor i5, but the latest versions.
నేను తినా నువ్వు తిను
So let me talk to one of my friends and I will get back to you, like what things they need to check up once. Okay. So coming back to our this part. So do we have any doubts with respect to unpaired sample t-test? Anyone? Anyone? Do we have any doubts with respect to unpaired sample t-test? Only one? Only two? That's it? Others? Others, please be quick. Okay, perfect. Okay, now I will show you one more extra thing. Now, if I say about a paired sample t-test, so if I perform a paired sample t-test in the SPSS, this will give me a very direct p-value. Done? A direct p-value will come. There is no other things here and there, nothing. Done? In the case of unpaired sample t-test, few more parameters will come up. So in the SPSS or Jamovi, EZR or any other application, whatever you are using or will be using in the future, will have a one test in the unpaired sample t test. That is what a Levine test. Done. So Levine test is like what? That will check your variance. So in simple word, what is variance? Your data distribution part. Done. I have seen many freshers in the statistical field having MSc in the statistics, but they have the same problem. I'm expecting same from you as well because even though you are learning, you might be having some sort of issue. So remember, Levine test is not a test for data normality. And for data normality, what test we are holding? We are holding Shiproville test and the Kolmogorov test. Then only two tests. That's it. Not any other test. Then Levine test is a test for distribution only in the unpaired sample t test. Then remember, now, if I say the very basic principles, if your p-value is less than 0.05, this will be as what? A significant part. I have seen many people reporting significant at 0.05 also, which is not possible. If it is 0.049, we can report a significant number. That is okay. Done. So remember this part. If Levine test is coming significant. Okay, to make it very simple, remember, now we have a two type of p-value. The one number will be what? Your less than 0.05. The other one will be what? A more than 0.05. Done? So the first one is what? The first one. This is a significant number. Done? What about the other one? It is more than 0.05. This is what? A non-significant in a very simple way. Doubts? Anyone? Questions? Anyone? Doubts? Question? No one? Okay. Now, whenever we are having Levine test with a significant p-value, we need to take, we need to take a p-value of equal variance not assumed. Done? Remember this part. So whenever our Levine test is coming significant, we need to take a p-value of what? Equal variance not assumed. Done? In the case of the next part, in which we have a non-significant Levine test, in such scenario, we will take a p-value in which we have equal variance assumed. Done? Remember this part, because in the unpaired sample t-test, you will get a two p-values and you should know which number to report. Sometimes what happen, both will be almost nearby same. Sometimes a difference of decimal part. But sometimes we have one number, one p-value in a significant direction, the other part in a non-significant direction. Then, even though your data is coming significant, but you might report a non-significant p-value. Then, so you should know this part. So do we have any doubts or any question for the Levine test, its p-value, and which number to report as per the significance data? Or like I should repeat again. Anyone? Any doubts, any question? Or should I repeat again? Because it's a very important part, very important part. Okay, repeat part, okay, done, no issue. See, there is no harm in asking again to repeat this part because if you miss a single step, you will miss the entire things. Done. So like don't take risk with the statistics part. Okay. Remember what we are learning. It's about the unpaired sample t-test. Correct? Now, in this part, we will get a one test that is known as Levine test. So Levine test is what? This will check for the data variance part. Done. So data variance, we need to check with the help of Levine test p-value part, like what number we are getting. So if you remember the very simple principles, if your p-value is less than 0.05, this will be what? A significant number. But if it is more than 0.05, this will be what? A non-significant number. Then, same way in the terms of Levine test, if we are getting a p-value, now it can be either significant or non-significant. Significant and non-significant. Then, if we are getting a Levine test, a significant p-value, in such scenario, you need to use a p-value of what? Equal variance not assumed. Not assumed. Simple. Done. In the case if Levine test is coming non-significant, you will report a p-value of equal variance assumed. Equal variance assumed. Simple. Any doubts, any question? Remember, in the unpaired sample t-test, we have one p-value, two p-value, and three p-value. Done. I have seen many people reporting in papers a Levine test number, but not the important numbers. Done. So this p-value will help you to identify which number actually we need to report. Correct? So you should know this part. If Levine test is coming significant, we will report a p-value of what? Equal variance not assumed. If it is coming, suppose a non-significant, we will report a p-value of what? Equal variance assumed. The entire things will be written in your SPSS also. Equal variance not assumed and assumed part. Right? So you should know which number we need to report. So do we have any doubts, any questions now? Anyone? Clear? Others? Utkarsh, Kartike? Significant, non-significant, it's like a p-value part, no? So if your p-value, see, this is all about p-value part, okay? So if your p-value is less than 0.05, if you can remember alpha part, the type one error part, we takes what? We take 5%, or if I change to number, that is what? 0.05. So whenever we are taking a p-value of less than 0.05, that will be what? A significant value. Done? Whenever we are comparing, remember one more part, the most important part, what I have seen in a very like a UG, PG people, like if they are giving me a single column, wait, not here. Suppose if they are giving me a single column, suppose X, Y, Z column with the entire data, they are looking for the p-value for this part as well. It's not possible. Done. And if you are getting a p-value, it something is wrong with your statistician, or he or she might not be a true statistician. A big problem. So whenever we are not comparing anything, whenever we are not comparing anything, there will no be a single p-value. You will never get a p-value if you are not comparing anything. To make it very simple for all of you, let me take a simple example for what? Utkarsh. Done. I can't compare Utkarsh with Utkarsh. Done. So if you've seen your parents, your friends, they will always compare you. Okay, yaar Utkarsh, your friend XYZ is much better than you, man. So this is what we are comparing Utkarsh with the XYZ friend. Correct? So in such scenario, we will get some significant number. But if I comparing Utkarsh with Utkarsh, I will never get a p-value. Done? Because Utkarsh cannot be compared with Utkarsh. We need something to compare Utkarsh with. Done? Then only we will get the p-value. Correct? Similarly, whenever we are going for the chi-square part, remember, chi-square is like what? Minimum 2 by 2 table. Suppose smoking, yes, no. Suppose lung cancer, yes, no. A simple part. Done. So we make a 2 by 2 table for this part. Done. Smoking, yes, no. Cancer, yes, no. This is what? A 2 by 2 table. We can go for 2 by n table also, like 2 by 3, 2 by 4, 2 by 5, all numbers. So in this part, we will get a chi-square value and the p-value as well. But what about whenever we are having a 2 by 1 table in this scenario? Suppose then all patients are lung cancer. Then all patients do smoke and no smoke. This is what? A 2 by 1 table. Then now the problem is, even though we have a smoking yes no, but we don't have a lung cancer yes no. So this is like what? A 2 by 1 table. Whenever we have a 2 by 1 table, we will never get a chi-square value and a p-value part. Done? Simple? Doubts? Anyone? Questions? So I hope we all are clear with the paired sample t-test and the paired sample t-test. And among that part also, I hope we all are done with the Levine test also. Anyone? Doubts or question? Or should I go to SPSS now? Anyone? Done? Others? Please be quick. Okay, no issue. So I will change to my desktop now. Just give me a couple of minutes. Okay. Sorry, actually my mic was mute, my mistake. So I hope you all have taken up the paired sample t-test. So what we are doing, go to file, go to open, go data. In the folder, whatever you have store all the files, click on that folder, change file of types to Excel part, and please import paired sample t-test. Click on this file, click on this file, click on open. This will give you a same sort of read Excel file block. In my Excel, we have only sheet 1. So let it be sheet 1. Directly click on OK. This is what we are getting now. So please open the paired sample t-test Excel sheet. All done? All done? Yes or no? Yes or no? So how many of you are like actually practicing with me now? Only two individuals? Okay, four individuals. That's it. 5, 6, 7. Perfect. Oh, 8, 9, 10. Perfect. Okay, good. Now the question comes. Remember the principles of paired sample t-test. Whenever we are comparing our score before after the intervention without creating any groups, no male, no female, even though in this group we have this gender part, male, female, male, female, male, female. We can have age distribution also, is completely fine. We do have a disease duration also in a couple of years, and we have pre-test and we have post-test. Then now I need to compare before my intervention, what was my score? After my intervention, whether score improved significantly or not. Then this is what I need to look for. After my intervention, whether the patient scores are improving or not, this is what I need to check for, irrespective of any groups. How to perform paired sample t-test? Go to analyze, go to compare means. If you can recall the iPad class, I wrote whenever we are comparing mean before after. Done mean part. So go to compare mean, go to paired sample t test. Done. Yes or no? Done. Simple till now. Go to analyze, compare mean and paired sample t test. Click on this part. Now this is the block what we are getting for the paired sample t test. Now what I will do, I will select a pre-test and transfer to variable 1. Automatically this got activated. Select post-test and transfer to variable 2. That's it. The next part is what? Everyone, please switch off your estimate effect size. This is not your part. It's completely our part. So remember effect size, what we had done in the first class, effect size, more the effect size, more known data, more like a well-known data. Correct? Remember the effect size part? So please switch off the estimate effect size, not required for your data as such of now. Done? Yes or no? Done till now? Done? Perfect. Now click on OK. That's it. Click on OK. Now what we are getting? We got a pre-test mean score, that is what, 13.31 plus minus 2.47. Done. What about post score? 16.88 plus minus 2.14. Done. So what I can say, okay, in the pre-test, my mean score was 13.31, but after my intervention, it changed to what? A 16.88. Done. Now, whether this is coming significant or not, we need to check a paired sample test, the third table. Done. In this part, what we will check? The last column, that is significant two-tailed. Done. Now remember, if you are holding a latest version, you might be getting a one tail, significant one tail. So how many of you are getting significant one tail in your option as well? Anyone? Anyone? How many of you are getting one tail in your p-value as well, apart from this two tail? No one? Am I audible? Yes or no? Please be quick. Please be quick. See, this is not a time pass class. So please be active for this class at least. So my simple question to all of you, how many of you are getting a one tail also? See, that's what I'm asking. This is same thing, two tail or one tail, the same thing. See, but you should know what is the major part, what we should know about this part. See, in this case, we have two tail. You might be having two or one side, correct? So you should know when to report one or when to report two side part or one or two tail part. Done. Suppose, let me frame a question for you. After this class, let me take one simple example, Vatsal. So after this class, Vatsal will top the class. Done. If in my question only, if I hold the answer or the analysis part, okay, after this class, Vatsal will top the class. In such scenario, we need to take what? A one tail or one side p value. Done. Let's see after this class who will top. whether Vatsal, yes or no. I'm not sure now. So what we will do? We will use a two-tail path. So to maintain the unbiasedness, to maintain the study power, we always go with what? A two-tail path, but not with the one-tail path. Then, so this is what you should know. Now I'm getting a significant number that is less than 0.001. Done? Yes or no? Yes or no? It's showing one side P and two side P less than 0.001. It's completely fine, no issue. But you should remember when to use which part. It rely on your question part, Rohit. If I'm saying, right, like a Rohit will top the UG exam now. Even if my question holds the answer, always go with what? A one side. Let's see who will top the UG exam. So I'm not sure about you at all. That time we have to go with what? A two-side TP value. Done? Done, Rohit? Yes or no? Okay. Now it is coming significant. So I can say, okay, after my intervention, there is a significant increase in the patient knowledge or patient score compared to baseline. Correct? Now I'm telling you one more thing. In the statistical world, a p-value is a completely useless word. Correct? Always rely on your numbers, whatever numbers, what I like showing to you. Now, suppose if it is coming significant now, the P number is coming significant. So this will give you a total green flag to investigate more why it is coming significant. Correct? Now suppose if in this class I am teaching all of you, I am getting a significant score improvement after my class. So we should investigate why this is coming significant. It can be multiple factors. So like, am I taking some extra classes for you? Am I torturing you just to sit and learn again? Am I torturing you to learn again by repeating a single step again? So, or like I am giving some question paper to you before the paper exam part done. So you need to investigate whatever the factors which can be involved in which we are getting a significant p-value. Then, but it's a kind of a advancing what we are talking about now. But you should remember, if my mean values are increasing, I'm getting a number less than 0.05, I can say, okay, there is a significant improvement in my patient scores compared to pre-score. Done? Doubts? Anyone? Questions? Anyone? Doubts? If my hypothesis is drug A is better than drug B, see, this is your hypothesis. You also need to frame your null hypothesis as well. Correct? So you can't say, okay, your drug A is always much better than drug B. This is your hypothesis. But in the protocol, you need to write your null hypothesis also. So in such scenario, you need to go with the two-tail part only, not one tail. Done, Karthike? Okay. Mean is minus 3 mean. See, minus 3. No, minus 3.57. This is nothing. 16.8 minus 13.3. That's it. 8 minus 3 is like what? 5? See, 5. Done? That's what. Done, Jaydeep? Done? Okay, perfect. So this is how we perform the paired sample t test. What is 95% interval of difference? This is the interval part. So suppose I am driving home. I know my way very well. So I will say, okay, I am 90% confidence. By this way, I will reach within 30 minutes. Then I will say, okay, I am pretty much sure. I am like 95% sure. By taking this way, I will reach home within 15 minutes. Then this is what the same principle we follow in the analysis part also. That is what a 95% CI interval. Done. This is what minus 4.0 minus 3.0. Done. So if I say what is my value, the mean part that is minus 3.5. So the lower part is what? Minus 4. Upper is what? Minus 3.0. Now the basic rule is your upper and lower should not be having a too much difference from a mean value. Then, if whenever you are having a lot of difference in your 95% CI, that means your data is not reliable at all. Correct? So whenever we are going for the odd ratio part, we always check your odd value, always comparing with 95% CI part, the upper and the lower part. Then in our scenario, what we have minus 3.5. What about the lower value? Minus 4.08. What about the upper value? That is minus 3.06. Done. So it's a pretty much in a good range only. So I'm okay. So I can say, okay, I can trust this data. Done. Done, Rohit? Okay, perfect. So this is how we perform paired sample t-test. So anyone, do we have any doubts, any questions for me till now with respect to paired sample t-test? Anyone? Anyone? No? Others? No? Perfect. The next step is what? A paired sample, unpaired sample t-test. So what we will do for the unpaired sample t-test, we will import the another Excel. So please go to File, go to Open, go to Data, change to Excel, and everyone please select your statistical analysis class practice sheet. Done. Select and open statistical analysis class practice sheet. Click on open. You will get this type of block. Click on OK. Done. Yes or no? Yes or no? Others? Shall I proceed now? Okay, perfect. Now remember, what is the principle behind the unpaired sample t-test whenever we are having the two groups and I need to compare a mean value between these two groups, or I need to compare a change in the mean value between this both the groups. Then now the second question comes, should I take more than two variables? Correct. Suppose UG, PG, PhD. No. As per the rules, we have to take only two groups whenever we are performing a Mann-Whitney U test or unpaired sample t test. Done. Why? Because automatically all the applications will give you only two variables to put up in a group part, either one, either two. That's it. Done. Now in the present Excel, we have a group that is case versus control. Done. Suppose one is case and two is control. To make it very simple for all of you. Done. One is what case, two is what control. Then I need to check among this case versus control, do we have a significant difference with respect to hemoglobin, with respect to HCT, with respect to RBC, or any continuous variable of your interest? To make it again simple for all of you, I need to check, do I have a difference between gender and the hemoglobin level? So we all know in female gender, we might be having a low hemoglobin count. So whether this is significant or not, this we can also check. Right? So what we will do, in our scenario, we have case versus control. Even though we have a gender part also, we can code them as well. But let's start with the case versus control ones. So how to perform a unpaired sample t-test? Again, go to analyze, go to compare mean, go to independent sample t-test. The third option. Done. A simple steps. Analyze, compare mean, and the third option. Done. If I click on this part, it's a kind of a different variables, the different block, whatever we are getting on the screen part. It has some additional options also. Now remember, I'm comparing case versus control now. So I will select case versus control and I will shift this part to a grouping variable. Why grouping variable? Because we have this thing as a group 1, 2. Correct? Case versus control, male versus female, UG versus PG, any two groups. It will come to what? A grouping variable. Now, if you all can appreciate, we have this two commas, comma, comma. I hope you all can see now this comma, comma. Yes or no? Yes or no? Yes, that means SPSS is asking you, please let me know what actually 1 and 2 means. Correct? So what I will do, I need to define the groups whatever I am giving to SPSS. Click on this part. Now group 1 is what? 1. Group 2 is what? 2. See, 1, 2, 1, 2, 1, 2. So suppose group 1 is what case, group 2 is what control. Click on continue. My first part is done. The other part is I want to compare all these variables with respect to case versus control. What I will do, let's suppose I'm checking hemoglobin transfer. I am checking HCT transfer. Suppose I'm checking PLT count transfer. Suppose I'm checking neutrophil count again transfer. So all the variables of your interest you can select and you can transfer for the analysis part. My second step is done. Third step, switch off the estimate effect size, not required for our side as such. Please tick off. Done. Other part is what option, nothing to be changed. Bootstrap is a very advanced part. I'm not teaching you bootstrap as such of now. Done. Ignore this part. Click on OK. Now see, we got a unpaired sample or independent sample t-test analysis now. So if I take a simple hemoglobin example in which we have case, we have control group. In case we have 50 patients and control we have 50 patients. Done. Now what is the mean score or mean hemoglobin in the case group? 9.55 plus minus 2.96. One part is done. Other part, in the control group, what is the mean value for hemoglobin? 10.44 plus minus 2.32. One part is done. Now I need to know, do I have a significant p-value comparing hemoglobin case versus control? So what I will do, I will check the next table. That is what? Unpaired sample t-test value. So I hope you all can appreciate a presence of Levine test here. Yes or no? Jaydeep is what? After select, please tell me, sir. What? Which part, Jaydeep? Options. Okay. So go to analyze, compare me, third option. Correct? See, nothing. Don't click anything here and there, Jaydeep. I just showed you like this is what. Just click on this cross button. That's it. And click on OK. Done? Done, Jaydeep? Okay. So like this is what we have now. So I hope this one part is done. The other part is what? A Levine test for the variance part. Now see, here we have SIG dot. This is what? A significant. Done. What about the significant p-value? This is significant or not? Yes or no? Please be quick. Yes or no? Is it significant or not? Yes. Why yes? Because p-value is what? Less than 0.05. Now, if Levine test is coming significant, I need to report a p-value of what? Equal variance not assumed. Done. Now, where is the p-value? Here. Significant two tail. Done. That is what? 0.096. Yes or no? Yes or no? Doubts or questions? Anyone? Simple? Simple, no? Let me take other example also. What about the HCT part? So if I ask you in the case group, what is the mean HCT? That is 30.54 plus minus 8.76. What about the control group? It is 28.15 plus minus 7.18. So if I see visually, okay, just a 2 point difference. Nothing to be like worried about. What about the p-value now? Come to the HCT part. The first part is what? A Levine test. Is it significant or not? Levine test is significant or not? Yes or no? Anyone? No? No? Perfect. So if Levine test is not significant, I will report a p-value of what? Equal variance assumed. Correct? So what will be my answer? 0.139. Yes or no? Yes or no? Doubts? Anyone? Question? Okay. Let's take one more example. In the PLT count, correct? It is coming significant for us. Let's see platelet count. So in the case group, we have a p-value of what? 158.26. In the control group, we have a p-value of 115.46. Okay, I can see, okay, something is coming significant because it's a kind of big difference, correct? So what I will check? I will check for the p-value part. This is the platelet count, PLT. Always check for the Levine test. It is what? 0.011, which means it is coming significant. If Levine test is significant, we report a p-value of what? Equal variance not assumed. And what is the p-value? 0.045. Yes or no? Ma'am, you remember that iPad part, ma'am? I showed that Levine test whether we have two options about the respective p-value. If Levine test is coming significant, we report a p-value of equal variance assumed. If not, we report a p-value of equal variance assumed. That's what, ma'am. Same here, ma'am. We have a Levine test here, ma'am. For Levine test, we have here this all p-values, ma'am. So if I take a hemoglobin as an example, if Levine test is coming significant, we report a p-value of equal variance not assumed. Correct, ma'am? If our Levine test is not significant, we report a p-value of equal variance assumed. So like, ma'am, based on the Levine test p-value, we need to select one number reporting out of the variance part. Now, if I take one more example for the PLT count, Levine test is like what? 0.011, which is less than 0.005. Done. If it is less than 0.05, I can say, okay, this is coming significant now. This Levine test for platelet count. If Levine test is significant, we report a p-value of equal variance not assumed. Done, ma'am? In such scenario, I will take a p-value of 0.045. Done, ma'am? Okay. Others? Doubts? Questions? Anyone? Clear? Sure? So like, do we have any doubts, any questions now? So actually, we should discuss this part more openly because this is what you are learning now. Others, do we have any doubts, any questions? This is what? A group statistics with Levine test. This is what? Please repeat. Which part, Jaideep? See, the thing is very simple now. If I'm knowing, okay, one is what case, two is what control. In case group, I have a mean value of 9.5. In the control, we have a value of 10.44. Then I need to report a p-value as well, correct? Now, for a single variable, we are getting two p-values. Even though same, but we are getting two p-value. If you see the third option, we have what? 0.44, 0.045. Some sort of difference will also come, correct? If I take, suppose, a simple example for PLT count, in the platelet count, check the first p-value of Levine test for this part, which is what? Coming significant, that is 0.011. It is less than 0.05, which means this is coming significant. So if your Levine test is significant, we report a p-value of equal variance not assumed. Now, where is the p-value for this part? This is here, 0.045. One part is done. Let me take the other example with respect to neutrophil. In the case of neutrophil, what is the p-value for Levine? This is 0.769, which is more than 0.05. So I can say, okay, for neutrophil, this is not a significant Levine test. If your Levine test is not significant, we report a p-value of equal variance assumed. That is what? 0.917. Done, Jaideep?
Excuse me, sir.
Ah, yes, ma'am.
Yeah, sorry to disturb you in the middle, sir.
No, no,
Actually,
please.
what I mean to ask is why we need to there is a two options, no, sir. Equal variance assumed and equal variance not assumed, right?
Correct, ma'am.
But in this significance, there is not that much variant difference, no, sir, in the values, sir. So, what is the need of the two? That is what my doubt exactly.
Okay. Now, ma'am, the thing is, in our data, we don't have that much difference, ma'am. But sometimes you will notice we have one part, suppose non-significant, the other part as a significant variable, ma'am. So let's test this part, ma'am. I hope something we get to show you all of this. Uh, just a minute, ma'am. Let me take my keyboard as well. Let me take all the variable ones. Let's hope we get something in a different way. Uh, so like in a simple way, ma'am, this variance is like what? How much your data is behaving in the unpaired sample t-test, ma'am. So we need to select a specific p-value for this part. Anything which is coming significant. Uh,
Like with those two values, what we are reporting, is it like in the manner of reporting process we are using that or something else?
it's a reporting process, ma'am.
Okay.
The thing is, ma'am, like even though we have a stable data, that's why we are using the unpaired sample t-test, ma'am. But
Mm-hmm.
unpaired sample t-test, we have two different groups, male versus female, suppose UG
Yeah, yeah.
versus PG. So
And
how they are behaving being a stable data, ma'am, that we need to check. That's why we are checking the variance, ma'am. So in a simple words, how much your data is distributed around the mean value, ma'am. That is your variance,
okay.
correct? So on that basis, ma'am, we have to select that part. So in this
Okay.
scenario, like nothing is coming in a significant or a different part. Okay. But ma'am, like once you will practice this part in your data, you might notice like for one variable, we have a non-significant value. For the other part, we have a significant value. You might notice this part, ma'am, for sure. So whenever we are seeing a Levine test which is coming significant, we report a p-value of equal variance not assumed, that is 0.096. If it is coming significant, non-significant, we report a p-value of equal variance assumed. That means my data is
Okay.
okay, okay,
Is
manageable.
that like a rule? Like when we got the significant, then we have to take not assumed variance.
Correct, ma'am. Only
Yeah,
the
okay,
Levine
got the
test, ma'am.
point.
If Levine test is coming significant, ma'am, we take not assumed. It's a rule.
Okay. Yeah, yeah,
Okay.
understood,
Even though
understood. That's
data
what,
is stable,
like the word itself, assumed, is confusing me that we need to assume something to put in that. Like that, I am getting, sir. That's
ma'am,
what
the
why.
problem is in
Okay.
statistics, we all have to assume, ma'am. Because
Okay,
if you
okay,
see
okay.
multiple tests, we are assuming things. Like
Yeah,
I
yeah.
think
Now I got it.
somebody
Okay,
of you have
okay.
asked for the hypothesis part.
So
So
that's
I
what
am
we
just
need to
assuming.
select that particular value when we are reporting at the time of.
Correct, ma'am.
Okay, got the
So
point.
even though,
Sorry,
ma'am, you
sorry.
make your protocol, no? So
Even though
in
it
your
is a
protocol,
basic one, but okay, I understood now. Okay, thank you.
okay, ma'am.
Thank you,
Okay.
thank you.
Others, like any doubt, any questions? Anyone with respect to Levine test and the p-value part? See, there are some certain rules we need to follow anyhow that we can't change. Now, suppose you are reporting, suppose, uh, let me take some random example because in this data, not a major difference we are getting. So I can't show that part. Okay. Almost nearby we are getting. Uh, no, nothing that much difference, but okay. But if you practice on your data, you will notice this thing. Like something will come in a two different north-south way. Done. So others, do we have any doubts, any question? I am directly getting significant value less than 0.05 highlighted. You might be have some sort of latest version, Rohit. Is it possible if you can share your screen, Rohit? Possible? Yes or no? No? Okay, no issues. Completely fine. Okay. Others, do we have any doubts, any questions? Anyone? Anyone? Doubts, questions? It's completely fine, Jaydeep. See, you write somewhere. If your p-value is less than 0.05, it will be significant. Either you take 0.01, you take 0.001, you take the 0.0001. This is always what? A significant. Even if you take 0.049, it is significant. Always take a number which is less than 0.05 will be always as a significant part. If it is 0.05, non-significant part. Then others, any doubts, any questions, anyone with respect to simple principles, with respect to analysis part, with respect to reporting part, anyone, any doubts, any questions. So I was planning to wind up your chi-square today as well, but I think we are running late now. But no issue. For the next class, we will take chi-square. We will touch some one-way ANOVA also. Remember, by learning the one-way ANOVA, it's not a simple part because we have a lot of post hoc analysis also done. You need to catch it very easily. So what I will do, not to make it very complex for all of you, tomorrow I will take chi-square, Mann-Whitney and Wilcoxon test. Done. So Mann-Whitney is what? A unpaired sample t-test for what? A unpaired sample t-test. If we have a paired sample t-test, we will take a Wilcoxon test. Sir Jaydeep doubt, can you explain as significance is reported at 1.2.3. Correct. It's a way of writing, Karthike. So, like whenever we are doing some sort of things, I can't show the other data to you, but whenever we are reporting some diagrams, or suppose we have some bar graph, we have some box plot, sometimes we can't write all the big numbers in a graphical presentation part. And so what we do, we write a single star, a double star, or triple star. So what a single star indicate a value less than 0.05, one part. What indicate by two stars less than 0.01. Remember, this is not exactly 0.01 like as per your message. This is less than 0.05, less than 0.01 and less than 0.001. Done. So whenever we are making some sort of diagrams, we can report in this way. Let me take one simple example for this part. It's actually a nice question what you have shown. So let me show this one part to you. Done. Let me take one quick example for all of you. How to report the star part. Then suppose if I am taking group A, suppose ALP, ALT, some random I'm taking some random numbers. Okay. So please do ask your friend about the SPSS. Yes, yes. But just now, please look at this data once. So if we have ALP, suppose I'm getting 12. Suppose this is what we have 40. Done. So if I go to the this part, suppose this part, correct? Now I need to make this star use. So I can say, okay, this is coming significant. So what I will do, I will go to this data. Suppose this part, I will take this part. I will just draw a single line like this. Done. Whenever we are having, suppose a p-value of less than 0.05, we will report as a single dot. That's This is what? A single dot. Done. If you want, if you have a data of less than 0.01, report with a two stars, or else 3 star in the case of less than 0.001. So this is how we report data in the graphical presentation. Done? Done, Karthike? The problem is there is no best p-value. This is like completely a wrong issue, whatever you are learning. So whenever we are having any number which is less than 0.05, that is what a significant p-value. That's it. So there is no term known as like highly significant, strongly significant, mild significant, nothing. Either we have significant or non-significant. That's it. Done. So don't depend on which number is more best. Okay. That is a different part, Jati. This is a different degree. that graphical presentation part. I just showed just to let you know when to use the star. Remember, whenever you are writing in the Word file, you are creating the tables. Don't write the stars in the p-value column. Write the actual value, whatever you are getting. Okay, not the stars. This is only for data graphical presentations. See, there is no notes for the statistical part. You just need to look at the YouTube link. So you can drop a message in the WhatsApp group, automatically team will share. No issue. Done. So I think we can wind up now if you don't have any questions or doubts for me. Sure, sure. Done. Okay, so I think we can wind up now. Thank you so much, everyone.